Now, the distribution of each individual bidder, the distribution from where these valuations are drawn from is from 0 to 10, right? Or 0 to 15? 0 to 10. Okay. Alright. So we are looking for, guys, we are looking for an equilibrium set of bidding strategies. In other words, how much would David bid in equilibrium, how much would Charlie bid in equilibrium, and how much would Ben bid in equilibrium. First price is option. Every one of them knows his valuation. Every one of them knows his valuation, but not the other bidder's valuation. Okay? So here we go. What is the optimal strategy for each bidder? The optimal strategy for each bidder is to take his valuation as the highest and bid the next highest valuation. Okay, let's see what Ben will bid. Ben's valuation is 2, so he will assume that 2 is the highest valuation. 2 is the highest valuation, and he will bid the next highest valuation. Okay, he will bid the next highest valuation. How many bidders are there here? If Ben is here, there are 2 other bidders here. Therefore, his optimal bid would be to find out where is the next highest bidder on average. He doesn't know the other bidder's valuation. So you break this distance down. This is 2 into 3 parts. 1, 2, 3. Therefore, the next highest valuation is here. Next highest valuation is here. What is that? It is 4 over 3. Okay, you break it down into 3 parts. So each part is, this distance is 2. Each part is 2 over 3. Therefore, you choose the second part. So times 2, 4 over 3. So the optimal bid of Ben is 4 over 3. Clear? Is that clear? You could use formula number 4 as well. But the reason I am using it, this is simpler to use than it is from 0 to 10. So as long as your distribution starts from 0, you could use this simpler way of finding out the expected next highest valuation. Okay? Alright, clear questions? This part is clear, yeah? So now let's look at Charlie. Charlie will assume his valuation to be the highest. This is true for Charlie. Will assume that 5 is the highest valuation, 5. And he will bid the expected next highest valuation in this distribution. Therefore, there are 2 other bidders here. He will break this line down into 3 parts. He will get 5 over 3. He will take the second part, 10 over 3. This is 10 over 3. Clear? Clear, guys? Not clear? The expected next highest valuation is this, right? Let me draw another diagram then. 0 to 10. For each bidder, how do you find his optimal bidding strategy? His optimal bidding strategy is found by assuming that his valuation is the highest. In the case of Charlie, Charlie assumes that his valuation is the highest and he looks for the next highest valuation. There are 2 other bidders here. That is Ben and David. So he has to place Ben and David somewhere here in this distribution. Okay, on average, Ben will lie here and David will lie here, or David will lie here, or Ben will lie here. He doesn't know, doesn't care. He's just looking for the expected next highest valuation. Therefore, he has to break this line segment into 3 parts and choose this guy. This is the second part. Here, therefore, it's 5 over 3. 3 parts means 5 over 3. Each individual line segment is 5 over 3. He is picking up the second part, 5 over 3 times 2, 10 over 3. Here. Similarly, David would assume that his valuation is the highest and bid the next highest valuation. So say 8 is here, David is here, green, David is here. He will assume this is the highest valuation, 8, and bid the next highest valuation. In other words, he is breaking down this line segment into 3 parts and choosing the second part. Therefore, if he breaks down this line segment into 3 parts, each part is equal to 8 over 3. He will take the second part, this point, that will be 2 times 8 over 3, that is 16 over 3. Yes? So the equilibrium bidding strategies for all players will be this. BD is equal to 4 over 3, BC is equal to 10 over 3, BD is equal to 16 over 3. This is the equilibrium set of bidding strategies. Now, ladies and gentlemen, I should also tell you, I am using this because it is very simple for me to use since I know the distribution and since I know each of the other bits. When you are doing it at home, you should also go back and try to derive the same result using calculus. How do you do it using calculus? For any bidder, ith bidder, for any bidder, the ith bidder, you can find out BI star using calculus. You have seen how to do that. You will make an assumption that every bidder believes that every other bidder is bidding a fraction of his valuation. Then you will find an expected payoff for the ith bidder in terms of the bid of his own bid, the other guy's bid, and the other guy's bid. You know how to do this. We have done this already. Okay? You will treat the valuation as being between 0 and 10. 0 and 10. Once you find the expected payoff, you should do the expected payoff for the ith bidder in terms of his own bid. Whatever you get, you should set it equal to 0 and solve here for BI star. Okay? Solve here for BI star. This will be a function, this will be some function, I guarantee you, of BI, of his valuation. It could be 1/2 BI, it could be 1/3 BI, it could be 1/4 BI, I don't care, it will be some valuation. Once you have found that, once you have found this function to find Ben's value, Ben's optimal bid, that means BB, you just substitute Ben's valuation, which is 2, into your function. So whatever this function is, you put 2 in here and get the result. And you will get the same result, I guarantee you, 4/3. Okay? Clear? So this can be done either via calculus or via assuming a bidder's valuation to be the highest and looking for the next highest valuation. Questions? Okay? Okay?